Great. Guys, let's get started. Welcome, everyone. And I'm going to lower everybody's hand right now. Welcome to Mathletes again. And I'm really excited today. Really excited. Now, what do you see in front of you? Do you see one of the great mathematicians? Do you guys see Brandon?
Come on, get back.
You all see Brandon?
Yeah.
And then look at Tess. That's Tess as well. So Tess made it onto a Mathlete dollar. And you know, based on some of the work that you guys did, I bet that all of you really worked hard enough to get onto a Mathlete dollar. So really cool. Now, I had some older students also make it onto a Mathlete dollar. And that was Alex and Andreas. And they did some really crazy math using factorials, which you guys aren't ready for yet, but it's pretty cool. It's pretty cool. Charlotte, do you have a question, love?
Yeah. No, I have a comment.
Yes, please.
Me and my dad, we did some factorial, but I don't know all of it. And also, me and my dad also found a lot of solutions.
Oh my gosh. Courtney, I am so excited. Can you tell me, sweetheart, can you tell me, Charlotte, sorry, I said Courtney. Charlotte, can you tell me, please, which was the one that you and your dad worked on with factorials? Do you remember?
Well, there was in the 6th column.
So when you had 6, 6, 6, 6?
Yeah.
Okay, tell me.
For the 10 one.
Oh.
It was 6 factorial. Divided by 6 plus 6 times 6.
Whoa.
Divided by 6 plus 6 times 6.
And I think all of that, you would have to then divide that by 6. And that would be 10. Wow, that is so cool. Please tell your dad that I'm really excited because I love anybody who does factorials. So much fun. Now, can you guys show me something right now? I'm going to show you something called powers of 10. Now, everybody, powers of 10 are like, well, they're not counting by 10. Can you guys first help me to count by 10? Let's do it. Ready, go. 10. Come on. 20. 30, 40, keep going.
50,
60, 70, 80, 90, and 100. Now, we could keep adding 10, but powers of 10 are much more special. Powers of 10 are all about repeated addition and then repeated multiplication. So we are going to have some fun with this today. Tess, do you have a question, Tess? And I think you're muted, honey. You'll have to unmute yourself. Go for it.
I figured out a lot of the problems.
Doing double side.
Say again there, Tess.
I figured out a lot of the problems.
Oh, Tess, I can't wait to see your work. Send me everything you have, especially since, Tess, you are one of those people on a Mathlete dollar. How cool is that? How cool is that? So much fun, and everybody is going to get on a Mathlete dollar at some point. Now, watch this, guys. Last week, we talked a little bit about exponents. So when you do something like,
Listen, this is important. Stop.
10 to the second power, that's
Okay.
not 10 times 2. That's 10
No.
times itself
Yeah.
twice.
10 times.
So who can say 10 times 10 equals what? Go.
100.
100. Now, what if we went one step further and we said 10 to the third power? Let's see what would happen.
Watch.
So 10 to the third power, and you guys, if you want, you can go to page 1 and do this with me. So if you go to page 1, under 10 to the third power, write down 10 times 10 times 10. And wait a minute, how many zeros are there in the 3 tens? How many zeros are there? Say it out loud. Go ahead. How many zeros are there? There are 3. So 10 times 10, which is 100, times 10 is 1 with 3 zeros. Who can say that number? On 3. 1, 2, 3, go. 1,000. And what if we did 10 to the fourth power? Everybody write it down. 10 times 10 times 10 times 10. Now we have
You
a
just write
1
down 4 zeros.
with 4 zeros. Now don't read the number yet. Don't read that
can
number
see.
yet. I want everybody thinking about it. I hope you wrote it down. I hope you wrote it down.
Look, 10.
Are you guys ready? Come on, let's do it.
Please.
On 3, 1, 2, 3, go.
10,000.
1,000. Say it again.
10,000.
10,000.
1,000.
And do you know that every time we say 1,000, we're dealing with 3 zeros?
See, look.
10,000. Who knows what the next one is going to be? Who thinks
Okay,
they
so
know what the next
10
one is going to be?
Times 10.
Who can raise their hand electronically? Will, do you know what the next one is going to be? You'll also have to unmute yourself. Go for it, Will.
100, 1,000.
Whoa! Do you think he's right? How many
Yes.
zeros would that be,
Yeah,
guys?
no.
100,000 has 5 zeros. Everybody say it out loud. 10 times 10 times 10 times 10. 5 times 10 to the 5th power. Oh my gosh. It is 100,000. Who's always ready for my favorite one? Camilla had a question. Go,
Okay,
Camilla.
goes there, okay?
No.
And Camilla, I think I
So
lost.
what is it?
Cam, did you have something to say, or maybe it was Gabby?
I just have a question about
Yes, Cam.
this. I'm thinking we might be able to go to Googleplex and the numbers and the.
Oh my God, Cam,
We might be
you
able
just
to go to
absolutely blew my mind. Guys, do you guys want to see what Cam just said? Do you guys want to see Googleplex? Now, it's kind of hard to see.
So there-
So
1, 2, 3, 4,
you're going to
5,
have
6.
to go to page 3 in your packet. If you go to page 3 in your packet, it shows you the names of really, really big numbers. Now, Cam, these numbers are huge. 1 million, 1 billion. Everybody go with me. 1 trillion, 1 quadrillion, 1 quintillion, 1 sextillion, 1 septillion, 1 octillion, 1 nonillion, 1 decillion, 1 undecillion, 1 duodecillion, and then look at Google. And then Cam, do you see Googleplex on the bottom?
Yeah,
And do you know?
but I can't really see your screen.
Oh,
I can't
you
really
can't?
see you.
Let's see.
Yeah, it's right here.
Let's see if
Oh wait, now
Kramer
I
can
can
make
see
it
it.
more visible
Now
to
I can
you.
see it.
And
Now I can
there
see
is
it.
Googleplex on the bottom. Now, guys, these numbers are so big, Now, everybody look at page
That's
number 2, where I give you the answers for all of these. And when we do 10 to the 7th, you're going to literally write 10 times 10 times 10 times 10 times 10 times 10 times 10, 7 times. And that's going to be 10 million because it's got 7 zeros in it. Now, guys, you're going to say, oh, Mr. Kramer, I don't know big numbers. But guess what? With powers of 10, it's really, really easy. Now, let me show you something else that I love. Mr. Kramer loves working with rulers. Does everybody see the big ruler on my screen?
Look, 10 million. Look.
The top part of my ruler is called
just
the
take-
metric system. And I'm going to mute everybody because I hear
Just
something in
take
the
7
background there. So the top part is called the metric system. The bottom part is our system of inches. Now, everybody do me a favor right now. I'm going to go to 100% screen. And I want everybody right now, do me a favor, hold up your knuckle. Hold up this knuckle of your forefinger. So it's when you take your forefinger and you bend it. Everybody do that right now and touch the top part of that knuckle. Touch the top, go like this, make sure this knuckle is horizontal and touch that top part. Now put it up on the screen at the 1 inch mark. That is approximately 1 inch. And if you look above it, it's the same thing at 2.5 centimeters. Now, it's pretty cool. If you ever want to measure 1 inch, take that knuckle and you'll be pretty close to either 1 inch or 2.5 centimeters. Now, we're going to go back to a larger display right now because who can tell me out loud, but don't say it yet, how many inches are there in 1 foot? And I'm not talking about a foot that you walk on. I'm talking about the measurement of 1 foot, and it's about this wide. Everybody say it on 3. 1, 2, 3, go.
12.
There are 12 inches in a foot. There are about 3 feet. Everybody go like this with their hands. Open your hands to about 1 yard. Now, 1 yard is 3 feet or 36 inches. You know, guys, that 1 yard is almost the same as 1 meter. Can you guys say 1 meter, please?
1 meter.
1 meter. Now, 1 meter. 1 meter is the way most people around the world talk about math. People around the world do not talk in feet, inches, and yards. There are only 3 countries in the world that use feet, inches, and yards. Does anybody know which countries those are? Can anybody tell me which countries those are? Cam, do you have your hand up, buddy?
Oh, I don't have my hand down.
Okay, Gabby, what about you? Do you know what countries?
I think it is South America, North America, South America, And I don't know what could be the other one.
Wow, you would not believe it, guys. But the United States, oh, Allie, do you have an idea?
Canada.
Ooh, interesting. The only 3 countries in the world are the United States. We use this thing called the imperial or customary measurement system. There's a country in Africa pretty close to the 0 to 0. It's 0 latitude, 0 longitude, and it's called Liberia. And then there's another country in Southeast Asia called Myanmar, and that's it. 3 countries. 95% of the world use what's called the metric system. 1 meter equals 100 centimeters. Everybody say that. 1 meter equals 100 centimeters. Hold up your pencil, please, right now. Hold up your pencil. The width of your pencil is about 1 centimeter. So everybody go like this and say 1 centimeter. This is 1 centimeter wide. 1 centimeter wide. And 100 of those make this, guys. 100 of those make 1 meter. Now, guys, it's so much fun to look at the metric system. I thought I would take a journey with you. Would you guys like to take a journey with me both into outer space and also down to the molecular level into atoms, the atomic structure of atoms? So from the largest things to the smallest things, would you guys like to take a journey? Who wants to take a journey? Raise your hand like this if you want to take a journey. All right, Jack, did you have something else, Jack?
Yeah, yes. Centimeter means 100 meters.
Well, it's the other way around, Jack. 100 centimeters, 100 of these, Jack, equals 1 meter. So 1 meter, which is like a yardstick, equals 100 of these centimeters. Does that make sense?
Yes.
Okay, great. And Jack, that was a great question. Are you guys ready? Now, I'm going to ask you very quickly to tell me this. I'm going to put up a video, and I don't know it.
Wait.
I'm going to
I can't
ask.
see your screen.
Hold on a
No,
second.
you can't. I can't. No, I can't.
Do you guys see the screen here?
No.
And hold on a second.
No.
Yes.
The screen should say pyramid. Do you see
Yes.
something that says
No, I
pyramid?
don't see it.
Yes.
Okay, great. Now, I
No.
want everybody to sit back and
No.
enjoy
Where
this
is it?
show. This is one of
It's
my
on mute.
favorite
I
things
don't
to do.
see it.
The video's on mute.
Say again?
The video's on mute.
Yes, and the video is going to stay on mute. And I just want, Gabby, I need a favor from you, Gabby. Are you
I
ready?
cannot see it.
Gabby,
Yes.
when I start the video, give me a thumbs up if you can hear me, okay,
Okay.
over the video. All right, here we go. This is the first time I'm doing this. Let's try it. So Gabby, are you ready? Gabby, can you hear me? Gabby, give me a thumbs up if you can hear me. Excellent. Okay, this film, everyone, was created in 1977 when Mr. Kramer was 15 years old. So I was 15 years old when I saw this video for the first time. It's called Powers of 10, The Effect of Adding Another Zero. and it's going to be a lot of fun. Now, this starts at a picnic near the lakeside in Chicago. It was the start of a lazy afternoon, 1 October, and it begins with a scene 1 meter wide, which we view from just 1 meter away. Now, do you guys remember that 10 to the 0th power equals 1? So if you notice, 10 to the 0 power is 1, and that is 1 meter. Everybody show me 1 meter right now. Come on, show me 1 meter. And that is, you are 1 meter away from these people. Now, guess what, guys? When I hit the button, it is going to go higher by a power of 10. 10 times higher. Are you ready? Here we go. And right now, that square you see is 10 to the 1st power, which is 10 of these. 10 of these is a little bit more than 30 feet high. Right now, the camera is 30 feet above the picnic goers at 10 to the 1st power. Every 10 seconds, we are going to look from 10 times further away, and our field of view will be 10 times wider. Now, you're going to see the picture center on the picnickers even after they have been lost to sight. And Cam, do you have a question, buddy?
Unmute. We can't see the screen.
We can't see your screen. We send you a message.
I will stop sharing, and I will share once again. That happens a couple of times each class. Do you see it now, Cam?
Now I can see. Now I can see.
Okay,
Yeah.
great. So I'm gonna mute you now. Okay, here we go. Everybody good. So here we go. We're gonna now go to 10 to the 2nd power. 10 to the 2nd power is 10 times 10, everybody. And what is that? This is 100 meters high. This is 100 meters. This is the distance that a person can run in 10 seconds. You can see cars crowding the highway. You can see power boats lying at their docks. You can even see the colorful bleachers at Soldiers Field as we continue to expand. At 10 to the 3rd meters, this square is 1 kilometer wide. 1 kilometer wide. It is pretty amazing. 1 kilometer is 1,000 meters. It's the distance that a racing car can travel in 10 seconds. We even can see the great city on Lakeshore Drive. 10 to the 4th power. This is 10,000 meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first around and the end of Lake Michigan, and then we can see the entire Great Lake. Guys, look at the lake forming at 10 to the 5th power. At 10 to the 5th power, which is 100,000 meters, the distance, which is of a hovering satellite covers in 10 seconds, you can see long parades of clouds, the day's weather in the Midwest near Chicago. At 10 to the 6th power, which is 1 million meters, which is a 1 with 6 zeros. Soon, the Earth will show as a solid sphere. We are able to see the entire Earth now just over a minute along our journey. We have just entered 10 to the 7th power, guys. This is pretty amazing. 10 to the 7th power is 10 million meters. The Earth diminishes into the distance, but those background stars are so much further away, they do not yet appear to move. Now at 10 to the 8th power, which is 100 million meters, you're gonna see a line that just extended to the speed of light. That line extended to the true speed of light in 1 second. It half crosses the tilted orbit of the moon. And that's what that is. We're now about to go 10 times higher to 10 to the 9th power. Oh my gosh, this is exciting. You can start to see the path of the Earth's orbit around the sun. What do you think is going to happen at 10 to the 9th power? And then 10 to the 10th power. Look at what happens. You can now see a smaller part of the path where the Earth revolves around the sun. And at 10 to the 11th power, which is 100 billion meters, now we can see the orbital paths of the neighboring planets, Venus, Mars, and then Mercury. Who would like to stop and who would like to go further away into the galaxies? Do you want to go further away? I see everybody going, keep going, Mr. Kramer, keep going, Mr. Kramer. Let's do it. All right, here we go. At 10 to the 12th power, which is 100 billion meters away, we see the orbital path now of the entire solar system. And we see the sun, followed by the massive outer planets swinging wide in their big orbits. And guess what we see at 10 to the 13th? That last orbit is my favorite planet. It's Pluto. That planet is Pluto, which was considered a dwarf planet for a while because it intersected with the orbit of Neptune, but now it is considered a real planet again. And Cam, you have a question. Go, buddy.
Can we go to a planet?
Can it go where, buddy?
Can you try to go to a planet?
Well, you know what? Watch what happens when we keep going further out. You're not going to be able to see, Cam, the planets anymore. This is the most amazing thing. Are you ready? Here we go. 10 to the 14th power. As the solar system shrinks to one bright point. Wait, let's see if we can get this to work. There we go. At 10 to the 14th, our sun is now the only star that is plainly visible. It's really, really hard to see. Now, as we go to 10 to the 15th power, guys, look what happened. This is 1,000 million. This is 1 quadrillion meters. And looking back from here, we can see 4 constellations still as much as they appear from Earth in the night sky. And this is 1 quadrillion meters away. Now, when we go to 10 to the 16th power, we now don't refer to it as meters anymore. Do you guys see what it says? It says 1 light year away, everybody. 1 light year away. That is the distance that it takes light to travel in 1 year. Now, you don't have the mathematical ability yet, but you will very soon to take the speed of light which is about 186,000 miles per second, and multiply it by 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year, and you will literally get around 6 trillion miles. Everyone, say the number 6 trillion, please, and then put your hand on your head, because I can't even think of something that big. 6 trillion miles. Oh my gosh. Who is ready to go to 10 to the 17th? 10 to the 17th, everyone, is going to be 10 light years away. And as you can see, the Earth diminishes into the distance, and they're so much farther, they don't even appear to move. At 100 light years away, guys.
Mr. Kramer, what was that big star right there?
Oh, let's go back a second, honey. Let's go back and see it. Ah, that star there might actually be the first star that is closest to the planet Earth. I think that that one is the first one closest to the planet Earth, and I think it's called Arcturus. Can you guys say Arcturus? Say Arcturus. Very good. Gabby, you had your hand up, honey.
But is it really the closest planet to the star? I mean, the star to the sun. Isn't the sun closer?
Well, we're not exactly sure, but it is considered one of the bright stars, and you can actually start to see some of the stars of the Big Dipper, everybody. I don't know if you can see it. It's really hard to see, but you know, I have to tell you, normally the stars and clouds of gas surround us as we traverse around the Milky Way. Are you ready to go around the Milky Way? At 10 to the 19th power, which is 1,000 light years away, giant steps carry us into the outskirts of our galaxy, and we pull away until we hit 10 to the 20th power. This is 10,000 light years, and we begin to see the great flat spiral facing us. Everyone, the time and path we chose to leave Chicago has brought us out of our galaxy along a course nearly perpendicular to its disk. And now, as we enter 100,000 light years, the two little satellite galaxies of our own are clouds of Magellan. Do you guys see our two little galaxies? Do you see our galaxies? Really cool. Now, at 10 to the 22nd power, yes, 1 million light years away, groups of galaxies bring a new level of structure to the scene. And oh my gosh, at 10 to the 23rd power, 10 million light years away, glowing points are no longer single stars, but whole galaxies of stars seen as one. Now guys, this is 100 million light years away. We pass a big cluster of galaxies. Now, as we approach the limits of our vision, we pause to start back home. This lonely scene, the galaxies like dust, is what most of space looks like. This emptiness is normal. Do you know that? The richness of our own neighborhood, our solar system, is actually considered the exception. Now, guys, part 2, the trip back to the picnic table will be sped up as reducing the distance to the Earth's surface by 1 power of 10 every 2 seconds. In each 2 seconds, we're going to appear to cover 90% of the remaining distance back to Earth. Now, I want you guys to watch what happens as the scene becomes great activity and great inactivity.
Mr. Kramer?
This is a rhythm that will continue all the way to our next goal. Our next goal, everyone, is a proton and a nucleus of a carbon atom beneath the skin on the hand of the sleeping man at the picnic. Now we're going to do 10 to the 12th power, 10 to the 11th, 10 to the 10th, 10 to the 9th, 10 to the 8th, 10 to, come on, help me guys, 10 to the 6th, 10 to the 5th, 10 to the 4th, 10 to the 3rd, 10 to the 2nd, and everyone, let's stop at 10 to the 1st power. This is 10 meters away, and now we are exactly 1 meter above the man on the picnic. Now, you guys aren't going to believe this, but we're now going to do negative exponents. You guys are in kindergarten, first, second grade, and guess what? You know how to cut things into tenths now. We're going to go from 1 meter, and we're going to cut it into 10 pieces. Each piece is about this big. Everybody show me. This is about 10 centimeters, everybody. This is about 10 centimeters.
Top of your head?
Yep, this is about 10 centimeters. In fact, I think my hand is about 10 centimeters wide. About 10 centimeters wide. Are you ready to do 10 to the negative 1 power? Are you guys ready? I can't believe it. Here we go. At 10 to the negative 1 power, we are going to go to 1 decimeter. That is called 1 decimeter, 10 to the negative 1. That's 10 centimeters. When we go 90% of the distance in, we go to 1 centimeter. 10 to the negative 2. Now, guys, you know what that is? 10 to the negative 2 is 1/100th. Because 10 to the 2nd power, 10 times 10 is 100. This is 1/100th of a meter. Remember what Jack told us? This is 1/100th of a meter. Cam, do you have a question, buddy?
Yeah, I do.
Go ahead.
How far can we go? How far can we go out and in?
Well, we've gone out to 10 to the 24th power, which is 100 million
I
light
also
years
have
away.
one more question. I have one more question.
Well, hold on. Let me answer your first question first. We are going to go in to, I think, 10 to the 16th power negative. So we're going to go into the atomic structure, even inside of atoms. Are you ready? And Cam, one more question, and then we have to keep going. Go for it.
Can we go inside that guy's skin?
That's where we're going right now. That's where we're going right now.
Awesome.
And if anybody wants to see this video, I put the link in your file so you can see it right afterwards. Victoria, you had a question, sweetheart.
It's kind of 2 things. So what's the galaxy that our planet's inside called? Or do they not have a name for it?
I'm pretty sure it's called the Milky Way. I am not the great scientist. I'm still a working mathematician, Victoria. So maybe you could do a little bit of research with Mom and Dad and figure out some of these questions and then share it with us next week. Sound like a deal?
Yeah.
All right, here we go. By the way, this video should generate about 1 million questions from you guys. You guys are going to have 1 billion questions. So here we go. Are you ready? I can't wait. So at 10 to the negative 2 power, at 10 to the negative 2 power, we approach the surface of the hand. At 10 to the negative 3rd, which is 1/1000th of a meter, which is 1 little millimeter. Everybody hold up their pencil. If you could take the lead out of your pencil, your lead of your pencil is about 1 millimeter thick. So if you could take the lead out of your pencil, that would be about, oh my gosh, look at Doris, everybody. Is that Doris? Doris, tell us what you're doing right now, honey.
I'm doing 1.5 centimeter.
Oh, wow. That is so cool. Alice, what did you have to say, honey?
Why does it have a square?
Oh, you have a square?
Yeah.
Awesome, awesome, awesome. All right, are you guys ready? Everybody pay really, really good attention and nice and quiet. Here we go. Mr. Kramer is going to go now to the next level. We're going to go 10 to the negative third. Now, I want to tell you what that was. We were entering the skin and crossing over layer after layer from the outermost dead cells into a tiny blood vessel underneath the cells. Now, we're going to go now at 10 microns close. These skin layers vanish in turn, and outer layers of cell called felty collagen, a capillary containing red blood cells, and a roughly lymphocyte. Pretty amazing stuff. Now, this picture is one of my favorites. At 10 to the negative fifth, which is 10 microns, we enter the white cell. Among its vital organelles, this porous wall of the nucleus appears. When we go to 1 micron, which is 10 to the negative sixth, the nucleus within holds the reality of man in a coils of DNA, everybody. DNA is what we're made of, and these are the coils of DNA. At 10 to the seventh power, which we call 1,000 angstroms, as we close in, we come to what's called the double helix, everybody. The double helix itself is a molecule like a long twisted ladder whose rungs of paired bases spell out twice in an alphabet of 4 letters the words of a powerful genetic message. And everybody has their own DNA makeup, their own special numbers that make up their message. Alice, go for it.
Why is the square going bigger and bigger?
Because we're going 10 times closer, Alice. Every time we go to another iteration, 10 to the negative seventh, 10 to the negative eighth, we are going 10 times closer inside the cell. Great question, sweetie, great question. Let's keep going so we can see the entire video, everyone. Here we go. Now we're going to go to 10 to the negative eighth power. And at 10 to the negative eighth power, this is 100 angstroms. This is at the atomic scale. The interplay of 4 electrons in motion become more visible now. Now we focus on one commonplace group of 3 hydrogen atoms bonded by electrical forces to make a carbon atom. 4 electrons make up the outer shell of the carbon itself, and they appear in quantum motion as a swarm of shimmering points. At 10 to the negative 10, which is 1 angstrom, guys, 1 angstrom is the size of an atom. We find ourselves right among the outer electrons. Now we come to the 2 inner electrons held in a tighter swarm. At 10 to the 11th power, as we draw towards the atom's attracting center, we enter a vast inner space. Everyone, does that look like outer space to you? Does that look like outer space? Well, guess what? It's reversed.
Yeah.
We are now inside the human body, and it looks like outer space. It looks like outer space. Here we go. At last, the carbon nucleus, so massive and so small. This carbon nucleus is made up of 6 protons and 6 neutrons. At 10 to the 13th, we are in the domain of universal modules. There are protons and neutrons in every nucleus, electrons in every atom, atoms bonded to every molecule out of the furthest galaxy. And I can't wait, guys, but we're about to enter a single proton fills our scene, and we reach the edge of present understanding. Poof, I can't tell you anymore because we don't know anymore. Even at 10 to the 15th power, we think these things are called quarks. Nobody really knows what they are, but they are really quite beautiful. Now, everybody tell me, did you love this video as much as Mr. Kramer did when I was 15 years old? Give me a thumbs up on this one if you did. Awesome. That is awesome. Now, what we're going to do is we're going to go back to our work. And I want everybody right now, let's see where we can go now. Ah, I think I know. Everybody right now, please go to page 8.
Need page 8.
Everybody go right now to page 8. Everybody go to page 8. And what I want you to do is look at this multiplication. Now, when you guys first heard multiplication, you were like, oh no, multiplication, I can't do multiplication. I'm just a little kid. Well, guess what? You can do multiplication just like anybody else. For instance, who can tell me what is 8 times 1?
8.
Why don't you guys write it down? Write it down a little further to the right. And now, who can tell me what is 8 times 10? All you have to do is add a 0, 1 0, onto the 8. And what do you guys get? Say it out loud.
8.
Now 8 times 100. Tack on 2 zeros.
800.
Oh my God, Camilla, that is right. 800. Who knows 8 times 1,000?
8,000.
Wait a minute. Who knows 8 times 10,000?
80,000. 80,000.
Now, guys, I was interested to see what you were going to do here. That 80,000 was the hardest one. That was the hardest one. And you guys can have some fun going through all of these problems this week. But guess what we're going to do? Are you ready? We're going to go to my next page. Now, you're not going to believe this. We are going to do 99 times 1. Everybody say it on 3. 1, 2, 3, go.
99 plus 1.
Everybody write down 99. And that is on page 9. And just so you know, there are answer keys for every single challenge. There are answer keys for every single challenge. Now, wait a minute. What happens when we do 99 times 10? Do we tack on 1 0? Let's tack on 1 0 and we get what?
990.
Yes, 990 is right. Now let's do another one. Let's tack on 2 zeros. And then we'll tack on 3 zeros. And then we'll tack on 4 zeros. And everyone, can you see how the zeros kind of form a triangle? Isn't that cool? The zeros actually form a triangle. And now you can write 99, 99, and 99. And we have 9,900, 99,000, 990,000. These numbers are huge. But guess who is now prepared? Because you guys are like astronauts. Do you know that astronomy is the study of large things? So astronomy is the study of great big things, outer space. Microscopy, everybody say that out loud. Microscopy, microscopy, and I'm going to spell it for you because I'm having trouble pronouncing it myself. No P. Microscopy. So the word is microscopy, and it's the study of small numbers. Small numbers is the study of microscopy. So when we went into the atomic level, we were studying microscopy. When we were at the outer space, we were studying astronomy, which is the study of big numbers. And I love big numbers and small numbers. All right, are you guys ready? The next one we're gonna do, oh, this one can be pretty easy, right? Let's try it together. What's 84 times 1?
84.
84.
84 times 10.
What's 84 times 2? Okay, turn this off and let's go.
840.
84 times 100.
8,400.
You can either say 8,400 or you can just say 8,400. And guys, can you see how the 2 zeros of the 100 correspond to the 2 zeros of 8,400? Can you see how the 3 zeros of 1,000 correspond to the 3 zeros of 99,000? Can you see how the 4 zeros of 10,000 correspond with the 4 zeros of 310,000? Now, to me, I love zeros. And that's why I taught it to you over the last few weeks, because I wanted you to be ready. I want to go to one more challenge. Let's go to page, let's see, we don't have to go there. Oh, I like this one. Everybody go to page 13. And the reason that I like page 13 is this. This is why I like page 13. Because it allows me to use 10 to the 0th power. Everybody, what is 10 to the 0th power? Say it out loud. 1, 2, 3, go.
1.
And 1 times 4 is what, everybody? What is 1 times 4? Is 4. Now, 10 to the 1st power. Say it on 3. 1, 2, 3, go.
1.
Is 10. And 4 times 10 is 40. And 4 times 100 is 400. And 4 times 1,000?
It's 4,000.
4,000.
Now, let's see if you can do the last one by yourself.
4,400.
Followed by 4 zeros. 1, 2, 3, 4.
40,000.
You guys got it.
40,000.
You guys got it. Now, I will tell you something. There is so much fun to have with zeros. Well, I want to show you how far we went into outer space. We went, I think, 10 to the 24th power, which was a 1 with 24 zeros. 3, 6, 9, 12, 15. Help me out, guys. 18, 21, 24. Now, everybody, we're going to start with the number -24 right now, and we're going to count up by 3s. Are you ready? Let's do it. -24. Go. -21. Go. -18. Go. -15. Go. -12. Wait, is it called 12? It's not 12. That's silly, but it is 12. And then let's go to the next one. -9. -6. -3. But don't ever say -0. 2, 4, 6, 8. Who do we appreciate? Mathletes. Mathletes. Go Mathletes. Now, guys, I will see you in 167 hours. If you really, really like big numbers, we can continue to explore the outer universe and science. Would you guys like to do that?
Yes.
All right. Come on this journey with me, and I'll see you guys in 1 week. All right, everybody. Remember, watch the video with your parents. And I also put in your packet a description of each and every slide in the video. Okay, Victoria, you have a question, love?
Yeah, it's more of a comment.
Yes, sweetie.
DNA is made out of genes. I learned that in Storybots.
That's true. That's true. That's true. That, you know, I'd love to hear your story someday. In fact, if you want to even write out a story about what you know about DNA and genes, I will read it. I will read it. All right, guys, I have to go. I'll see you in 167 hours. Bye-bye.
Bye.